Hello students, in this video today we are going to solve the problems of exercise 5.8 of mathematics class 12 NCERT. And here our main topics are Rowley's theorem and mean value theorem. Okay, so before we solve the problems, let me tell you some important points, and also let me tell you that I have provided a link of one video on continuity and differentiability of functions. So please watch that video first for better understanding. So before we solve the problems, let me tell you some very important points on continuity of function, which is going to help you to solve in solving the problems of this exercise. And first point is a polynomial function of this form is always continuous at each point of its domain. And also remember, a function, rational function, that means which is of the form of px by qx, where px and qx, these two are also polynomial functions, and if qx is not equal to 0, then it is always continuous at all points of its domain. And sin x and cos x are also continuous at all points of its domain. And similarly, exponential functions and logarithmic functions are also continuous at each point of its domain. Okay, so remember those points. If you pause the video, you can note the points. It will be helpful if you note it. Okay, so now let's start. Let us solve the problems. Okay, so in the first question, a function is given f of x square minus plus twice x minus 8, and x belongs to closed interval from -4 to +2. So we need to verify, in this question we need to verify the Rowley's theorem. So first let me tell you what is Rowley's theorem. Now according to Rowley's theorem, if you see, if we have a function f and its domain is closed interval a to b and the range is R, then if this function is continuous in the closed interval -4 to 2, I should write here a to b. Okay, as the question is given here -4 to 2, I have written here -4 to 2. So let me use a to b. Okay, let me use here a to b. Okay, because in the theorem, as I am writing here a and b, so let me use a and b. Okay, so here will be a and b. So now you see, this function, if this function is continuous in this closed interval, and if it is differentiable in this open interval a to b, and also f of a is equal to f of b, if these three conditions satisfied, then there must exist a c which belongs to open interval a to b, such that f dash c is equal to 0. So that is the Rowley's theorem. Now you see how to verify this. In this case, here you see this function is polynomial function. Here you can see this function is polynomial function, and I have already told you that polynomial function is always continuous as well as differentiable. Okay, also differentiable. So here you see, so now f of x is polynomial function, so it is continuous at its point in -4 to 2 and differentiable in the open interval -4 to 2. Remember that. So now let me check, does it satisfy this condition, third condition, f of a is equal to f of b. Let me check. So f of a, instead of a we have here -4, so f of -4. So if you put here minus 4, then what you will get, minus 4 square, then 2 into minus 4 and minus 8. So that's gonna give you 16 minus 8 minus 8, that's equal to 0, isn't it? So let's find f of 2. Then it's gonna be 2 square minus 2 plus 2 into 2 minus 8. So that's gonna be 4 minus 8, that's gonna be 0. So here you can see in this case f of minus 4, let me scroll down, f of minus 4 is equal to f of plus 2. So here you see third condition is satisfied, this condition is satisfied. Okay, as it is polynomial function, it must be continuous and differentiable, and also it satisfy this condition. So here Rowley's theorem is applicable, isn't it? So Rowley's theorem is applicable. So we have shown that this theorem is applicable here, not verified yet. Okay, it is not verified yet. So to verify, we have to check is there any real number c in its in the open interval a to b. So in this case it will be minus 4 to plus 2. If there are any real number in this minus 4 to 2 range, so that f dash c is equal to 0. So first let us find f dash c. So first let us find f dash from this function. That means let us differentiate this function with respect to x. So if you differentiate this function f of x, then what you will get, so f dash of x will be equal to, so first term is x square, so it's going to be twice x, and next term is twice x. So if you differentiate it will give you 2 only, and next term is constant, so it's going to be 0. So f dash is this one. So suppose let us consider c belongs to minus 4 to 2 such that f dash c is equal to 0. Okay, if this number let me find the value of c which satisfies this condition. If that value belongs to or lies within this range, then Rowley's theorem will be satisfied, Rowley's theorem will be verified. Okay, so f dash c, if you put here c, then what you will get, 2c plus 2, that's equal to 0. Then c, that's minus 2, and c is equal to minus 2 by 2, that's going to be minus 1. Now you see this is this belongs to minus 4 to 2. Yes, this is minus 1, so it is greater than minus 4, less than 2. So that's why Rowley's theorem is verified. So hope you have understood. So before we solve the next problem, let me tell you one more important thing. If this function, if you need to check is this differentiable or not, so to examine that, first find f dash x, that means differentiate the function, then evaluate here domain is a to b. So first evaluate f dash of a and f dash of b. If the results are real, then differentiable. If this function is differentiable, and then it must be continuous. So remember that point. Okay, now let's move on to next question. Question number 2. So our next question, examine if the Rowley's theorem is applicable to any of the following functions. So there are 3 functions here. So we have to examine Rowley's theorem is applicable or not. And here also asks that, can you say something about the converse Rowley's theorem from these examples? First, let me check Rowley's theorem is applicable or not. So let me use the, okay. So here the first function, the first one is f of x. So this is greatest integer function 4. Here the domain is x belongs to close interval 5 to 9. Okay, so if you draw the graph of the greatest integer function, here you can see, then you will get a graph something like this. Suppose this is 0 and we have suppose 5 is here, and this is 6 7 8, so this is 9 suppose. Okay, similarly here it is 5 6 7 8, and this is 9. So if you draw the graph, then you will get. So here you see, as it is greatest integer function for any value which is greater than equal to 5 and less than 6, so it remains 5. So graph should be something like this. And so similarly here, if the x is greater than equal to 6 and less than 7, then it will be here. So similarly we will get this kind of graph. Okay, so from the graph it is clear that it is not continuous. Okay, if it is not continuous, then we are not going to check it is differentiable or not. Okay, so if it is not continuous, then Rowley's theorem is not applicable. Okay, so so here you see, from the graph it is clear that it is not continuous. But remember one thing, greatest integer function are discontinuous, they are not continuous, remember that. So you can write simply as it is greatest integer function it is not continuous, and hence, as you can see, it is not continuous, so Rowley's theorem is not applicable. Rowley's theorem is not applicable. And also we need to check, can you say something about the converse Rowley's theorem? Now you see, if you see here in this graph, between 5 and 6, this graph is parallel to x-axis. Parallel to x-axis means y is constant. That means f of x, y equal to f of x must be a constant. It is 5 or whatever it is. So if you differentiate it, then you will get 0. That means there is a real number between this, not only one, many real numbers, infinite number of real numbers for which f dash c is equal to 0. And but let me check that converse Rowley one condition is satisfied, that we have f dash c is equal to 0, c belongs to fn 9. But let me check this condition is applicable or not. F of 5 is equal to f of 9 or not. So then we will check the other conditions. So if you find f of 5, then what you will get? F of 5 is 5, f of 9 is 9. It is obviously not equal. F of 5 is not equal to f of 9. So converse Rowley's theorem is also not applicable. Converse Rowley's theorem is also not applicable. So hope you have understood this. So next one is similar to this first one. So let me solve number 3. So number 2, try yourself. Okay, so number 3, so what is the function here? Here the given function f of x. So number 3, this is the given function. Here you can see it is a polynomial function. So if it is polynomial, then it satisfies the first two conditions of Rowley's theorem, that is continuous and differentiable. In 1 to 2 and open interval from 1 to 2. Okay, first two conditions are satisfied by this function. But let me check f of 1 is equal to f of 2 or not. So f of 1 will be 1 square minus 1, that's going to be 0. F of 2 is equal to 2 square minus 1, that's going to be equal to 3. So as f of 1 is not equal to f of 2, so that's why here also Rowley's theorem is not applicable. So Rowley's theorem is not applicable. Similarly, if you check the converse Rowley's theorem, then also you will get it is not applicable. Okay, so hope you have understood till this. Now let's move on to next question. Question number 3. Now in the third question is given that this function is differentiable, and if f dash x doesn't vanish, so that means f of f dash x never becomes equal to 0. So anywhere it's never become 0 anywhere, then we need to prove f of minus 5 is not equal to f of 5. So how to prove that? Now according to Rowley's theorem, so according to the Rowley's theorem, so what was the Rowley's theorem? Let me write it. So according to this Rowley's theorem, if f is a function in the domain a to b or closed interval a to b and range is r, then if f is continuous in this closed interval and f is differentiable in this open interval a to b, and also if f of a is equal to f of b, then there must exist f dash c is equal to 0 for c belongs to open interval a and b from a to b. So here in the question it is given that in this case f dash x doesn't vanish. That means, so it is given in the question that let me make it bold. Okay, as it is given f dash c is not equal to 0, then by Rowley's theorem this condition should not be satisfied. So f of a should not be equal to f of b. Okay, so therefore for this function, for f of for the function from close interval minus 5 to plus 5, and the range is suppose r, for this function f of minus 5 is not equal to f of 5. So hence proof. That's all what we should do so to verify this or to prove this. Now let's move on to next question, question number 4. So to solve question number 4, we must know the mean value theorem. So let me tell you the mean value theorem. So according to mean value theorem, suppose we have a function, this f, and here it is domain and this is the range, and f is continuous in its domain and differentiable in the open interval a to b. If in this case, if f of a is not equal to b, f of b, then there exists a number c which is in the open interval a to b, so that f dash of c is equal to f of b minus f of a is equal divided by b minus a. So now we are going to verify this in question number 4. Verify mean value theorem. This function is given here, and domain is given a to b, where a is equal to 1, b is equal to 4. So let me show you how to solve this problem. So first let me make it bold. Okay, so solution. So here you see the function f of x is given x square minus 4x minus 3. Okay, this is the function, and here x belongs to a is 1, b is 4. So let me write here 1 and 4 directly, 1 and 4. Okay, so as it is polynomial function, since it is polynomial function, so it is continuous in the interval 1 to 4 and differentiable differentiable in open interval 1 to 4. Okay, so now let me check if it is if it is satisfy this condition, third condition, or not. So let me find f of 1. So f of 1 is here 1 square minus 4 into 1 is minus 3, that's going to be minus 6, and f of 4, that's going to be equal to 4 square minus 4 into 4 minus 3, that's going to be equal to minus 3. Okay, so here third condition also satisfied, f of 1 is not equal to f of 4, so these two are not equal. So now we can say that all the three conditions are satisfied. It is continuous, differentiable, and f of 1 is not equal to f of 4. So that's why we can say that the mean value theorem is applicable. So mean value theorem is applicable. Okay, so now let us verify it. So to verify it, let me scroll down a page. So first let us find f dash x. So here you see, in this case f of x is this one. So if you differentiate it, if you differentiate x squared, then you will get twice x. If you differentiate minus 4x, then you will get minus 4, and this is going to be 0. So f dash x, that's going to be twice x minus 4. Okay, so let us consider that let c belongs to this open interval a and b. So instead of a, there will be 1 and b is 4, such that f dash c is equal to f of 1 minus, f of 1, not 1 here, f of 4. F of b should be f of 4 minus f of 1 is equal to 4 minus 1. So now if the value of c, if this value of c lies in the interval 1 and 4, then we can say it is verified, mean value theorem is verified. So in that case, so let us find that. So f dash of x is this, so f dash of c must be twice c minus 4, and on the other hand, so we have got f of 4 is minus 3, so let's put here minus 3, and f of 1 is minus 6, so minus 6, so it will be minus minus plus. So here b minus 1, so b is 4 and 1 is a is 1, so here b minus a, that's going to be 4 minus 1. So here it will be 3, and this is also 3, that's going to be equal to 1. So we can say twice c is equal to 1 plus 4, that's equal to 5. So c will be 5 by 2. 5 by 2. So 5 by 2, this belongs to 1 comma 4, open interval 1 comma 4. Therefore we can say, therefore mean value theorem is verified. So hope you have understood this. Now let's move on to next question. 5. Here we need to verify again mean value theorem. So this is the given function. This is also a polynomial function, and the interval is given here, closed interval a to b, where a is 1, b is 3. So we need to find c belongs to 1, 3, for which f dash c is equal to 0. So now first let us verify the mean value theorem. Okay, so now let me solve this. Okay, the function f of x is equal to here x cube minus 5x square minus thrice x, and here x belongs to closed interval a to b, where a is equal to 1, b is equal to 3. So now as you can see, as it is a polynomial function hence it is continuous in the closed interval a to b and differentiable in the open interval 1 to 3. So first two conditions are satisfied. Now let us find f of a, that's going to be here in this case f of 1. So f of 1 is 1 cube minus 5 into 1 square 3 into 1, that's going to be equal to minus 7, I think, yes, minus 7. Okay, and f of b, so in this case f of 3, that's going to be 3 cube minus 5 into 3 square minus 3 into 1, sorry, not 1, it will be 3 into 3. So that's going to be equal to minus 27. If you calculate this, you will get minus 27. Now here you see third condition also satisfied. F of a is not equal to here f of b. So mean value theorem. So mean value theorem is applicable. So there must be a number c, suppose c belongs to open interval a to b, such that f dash c is equal to f of b minus f of a by b minus a. So f dash c. Now let us find f dash x first. So what will be f dash x? If you differentiate this function, then you can have thrice x square minus 10x then minus 3. You can have this. Okay, so for c, then you will get 3c square minus 10c minus 3, and f of b we have got minus 27, then minus, and f of a is minus 7, so here it will be plus 7 now. Then b minus a minus b is 3 and a is 1 here, so it's going to be equal to minus 20 by 2, that's going to be minus 10. Okay, so simplifying this, you will get 3c square minus 10c minus 3 plus 10 is equal to 0, and that's going to be 3c square minus 10c plus 7 is equal to 0, and which can be factorized as minus 7c minus 3c plus 7 is equal to 0. On taking c common, you will get 3c minus 7. On the other side, minus 1 will be common. 3c minus 7 is equal to 0, which implies that 3c minus 7 into c minus 1 is equal to 0. So therefore you will get 3c minus 7 is equal to 0, and or you can write c minus 1 is equal to 0, which implies c 7 by 3 or c is equal to 1. So c is equal to 1, it doesn't belong to open interval 1 to 3. Okay, but it does. 7 by 3 does. 1 to 3, it belongs to open interval 1 to 3. So we can say, as this value 7 by 3 belongs to this open interval 1 to 3, because 7 by 3 will be 2 point something, isn't it? So 2.33 maybe, which is in the open interval 1 to 3. So that's why mean value theorem is verified. Mean value theorem is verified. And one more thing, as we have got f of a is not equal to f of b, so by Rowley's theorem, f dash c is not equal to 0 for c belongs to 1 to 3, open interval 1 to 3, it doesn't exist. F dash c equal to 0 doesn't exist. It is not equal to 0. Okay, so remember that. So we can say f dash c is equal to 0 does not exist. So here is question number 6. Now we need to examine the applicability of mean value theorem for these three functions. So for these three functions, is mean value theorem applicable or not? So now you see these two are greatest integer function, as already we have done in question number, I think question number 2, isn't it, in for Rowley's theorem. So as these are greatest integer function, so it cannot be continuous and differentiable. So that's why here we cannot apply mean value theorem. I'm not going to write all those things, as already we have done such kind of functions to verify Rowley's theorem. So these two are not continuous and not differentiable in their domain. So first two conditions of mean value theorem are not satisfied by these two functions. So let me check the third one. So this is the third one, f of x. So number 3, we are going to solve the third one, is x square minus 1 for x belongs to 1, 2. So it is polynomial function. It is polynomial function. So it is continuous in the domain 1 to 2, close interval 1 to 2, and differentiable in open interval 1 to 2. So first two conditions are satisfied. So let me check the next two conditions, that is f of a and f of b. So here f of 1 will be 1 square minus 1, that's going to be 0, and f of 2, that's going to be equal to 2 square minus 1, that's going to be equal to, I think, 3. So f of 1 is not equal to f of 2. So mean value theorem is applicable here. Mean value theorem is applicable. So there must be f dash c, so we can write there exists c belongs to 1 to 3, 1 to not 3, here 2, the open interval 1 to 2, such that f dash c is equal to f of 2 minus f of 1 by 2 minus 1. Okay, so we have got this. Now you see, now in order to find c, let me find f dash x first. So from this function, f dash x will be twice x only. So here you see, we can say here for f dash c it will be twice c. So f of 2 we have got here 3, so 3, f of 1 is 0, 3 minus 0, and 2 minus 1 is 1, so it's going to be 3 only. So c will be equal to 3 by 2. That belongs to the open interval 1 to 2. So because 3 by 2 is 1.5, isn't it? So mean value theorem is verified. So hope you have understood. If you have understood, please share the video with your friends, and if you are new to my channel, please subscribe the channel and hit the thumbs up button. Thank you for watching.